This diagram is misleading because the widths are not equal. So the widths have no real meaning. It's the heights that tell you about the large and the standard tins. And to sort of exaggerate it, what if I said that this was how much paint you got from the large tin? At that point, you'd be like, why have you made this really long? But it's sort of been subtly done here, and it can make it, you can just it can make you just think that something is better than it actually is. So we should be making the widths the same, and they're not. The widths of the bars are not equal. Okay, then we've got a standard tin of paint and a large tin, and they're both cylinders. That's actually not going to be massively important. But if they're mathematically similar, what it means is if I knew the diameter of one, then I would multiply by something to get the diameter of the other. But the same would also be true for the height. I would multiply by that same thing to get the height of the larger one. But we're not told that length scale factor, that's what we call it. We're told the volume scale factor. So we're told that the volume of the larger tin is 50% more than the volume of the standard tin. So what would I do? If I want to increase by 50%, then I want 150%, and then that gives me a multiplier of 1.5, and the volume scale factor is 1.5. To go from the volume of the smaller one to the larger one, I multiplied by 1.5. How to get back to the length scale factor, because that's what I want. I want to know what I multiply the radius by to get the radius of the larger tin. Well, let's say we have two cubes that are mathematically similar. Okay, this is a 1 by 1 by 1 cube. It will have a volume of 1. And then 2 by 2 by 2 cube, which will give me a volume of 8. Well, the length scale factor is 2. But the volume scale factor is actually 2 cubed because for every length I'm multiplying by 2, so overall for the volume I have to multiply by 2 cubed. And that works in general. The length scale factor, if I cube it, I'll get the volume scale factor. That will work for any similar volumes. And the opposite is true. If I have the volume scale factor, I could cube root it to get the length scale factor. So the length scale factor here is the cube root of 1.5. And I'm basically done. The radius is going to equal 10 times the length scale factor, which is the cube root of 1.5. I can put this into my calculator. Oh, I've done it already here. 11.4471. Sorry, was it 4471? 4471. Okay, just write that in full and then round it to say 3 significant figures. It's really hard to do this question. Like, even though it tells you it's a cylinder, you don't know the heights of them. So trying to actually work out the volume of a cylinder, I did have a quick go, and it just gets messy. So much better to learn the link between length scale factor, volume scale factor, and surface area scale factors, which I'm not going to go into here, and be able to deal with them and go from volumes or areas of shapes to the other similar shape.